Section 4.5 Integration by Substitution. As you know, so many functions that we are dealing with are composite functions. In this section, you will learn how to integrate composite functions. Such a technique is called integration by substitution. This technique is comparable to the role of the chain rule in differentiation of composite functions. Let's start. Substitution rule for indefinite integrals. Sometimes we can rewrite an integral to a simpler form. So right now, you're going to have to see the pattern here. You are looking at integral of f of g of x, which you know is a composite function. And next to it, it is multiplied by g prime of x dx. If you see a pattern like that, we can substitute g of x by letting g of x to be u, so that you can substitute as f of u, and because you let u equal g of x, if you take the derivative each side, derivative of u is 1 du, and derivative of gx is g prime of x dx. So this g prime of x dx, you're gonna replace it by du. So now du sitting in here. So now look at, originally we had the integral of f of g of x times g prime of x dx. Now it is much simpler. It is now integral of f of u du. And all you have to do is now integrate this with respect to u, so that you can recover antiderivative of small fu, which is capital Fu plus c, and at the end of integration, you can substitute back what the u was. Remember, at the beginning, you're the one who created a u and called the gx as u. So at the end of integration, you have to replace back what the u was, and that will be g of x. So you will have f of g of x plus c, and that will be your answer. Once you recognize the pattern, it is not that hard. Let's do some examples here. What is the integral of fifth power of a quantity x cubed plus 7 times 3x squared dx? What is my u here? Well, look for the composite function. You are going to call the inner function of a composite function u. I see only one composite function in this product. This is a composite function. It's a function raised to the fifth power. And the inner function of that is just this. So I'm going to call that u. So my u is equal to x to the third plus 7. And once you write that, take the derivative each side. So derivative of u is du. It's a 1 du, which is just du. And then when you take the derivative of right hand side, you get 3x squared dx. And that's exactly what is multiplied right next to the composite function. So now you're going to substitute x to the third plus 7 by u. You're going to substitute 3x squared dx by du. So then my integral just become integral of u to the fifth power du. Look at that. That became so easy integral now. So now I'm just going to use power rule for integral. Integral of u to the fifth power du is, we're going to gain 1 power. So it's going to become u to the sixth power divided by the power plus c. But look at the original integral. I don't have any u there. My answer better be in x. So you are going to have to finally do the back substitution of u. And at the beginning, remember, this is your u. So now you have to substitute back what the u was. And what was u at the beginning? You call the u equal x cubed plus 7. So u is x cubed plus 7 raised to the 6th power over 6 plus c is my answer. Easy, right? Not too bad. Let's do another one. What is the integral of sine cube of x times cosine x dx? Again, what are you looking for? You're gonna looking for the composite function. And what is a composite function? It's a function raised to the 3rd power. That's your composite function. What would be the inner function of that? That's a sine x. So you're gonna let u be inner function of your composite function, which is sine of x. Now take the derivative each side. So derivative of u is du, and derivative of sine x is cosine x dx. And look at that. That's exactly what you have for du right next to sine cube of x. Yeah? So now we're gonna substitute. This become integral of, remember your u is sine x, so you would have a u cubed now. And cosine x dx is your du. Wow. So easy integration again, right? Like a miracle. So now you take the integral of that, which is u to the 4th power divided by 4 plus c. And now my answer better be in x. So we do back substitution at the end, what the u was. U at the beginning, it was sine x. So the final answer is sine 4th x over 4 plus c. So you found your answer. Let's do a couple more examples. Integral of 2x square root of quantity x squared plus 1 dx. Which one is composite function? It is very obvious, right? It's a square root of x squared plus 1. And inner function of that is x squared plus 1. So let u be x squared plus 1. And you can take the derivative of each side. Derivative of u is du, and derivative of x squared plus 1 is 2x dx. Do you have it? Yes, I do. Now, let's rewrite this as a power. So what I have is x squared plus 1 to the 1/2 power. I'm gonna write 2x on the back. And you know multiplication is commutative, so I can switch the order. I already determined my u du. So now you can actually substitute. And when you substitute, x squared plus 1 was your u. So now you have a u to the 1/2 power. And 2x dx can be replaced by du. Correct. So now we can use power rule for integral. And we can add 1 power to 1/2 power, which is 3 over 2. And since my power is fraction, you can multiply by reciprocal instead of dividing by a fraction. So I have 2/3 u to the 3/2 power plus c. And what is your last step? Yes, you gotta do back substitution and plug back what the u was. And our u was x squared plus 1 to the 3/2 power plus c, and that is your answer. How about integral of secant square x over 5 times tangent of x over 5 dx? So what's my u? Which one? Secant That would work. But this time, you could look at also tangent of x over 5 as a composite function, because inner function is x over 5 and outer function would be tangent. So you could do it that way. Either way is fine. Because there is a power on secant x over 5, more like you would have thought composition function was the secant square of x over 5. So let's do it that way. If you thought secant square of x over 5 was composition of a function, then your inner function would be secant of x over 5. Then when you take the derivative of each side, then I get derivative of u is 1 du, which is just du, and derivative of secant x over 5 is secant x over 5 tangent x over 5. I need the chain rule here. I gotta multiply by 1/5, which is derivative of x over 5 dx. And I can rewrite this integral now as integral of secant x over 5. So I can call that a u. But I had two of them, right? Secant square x over 5. So just split them and have another secant x over 5 in the product times tangent x over 5 dx. Are you ready to substitute? Do you have any problem here? Yes, we have a problem. What's wrong? There is 1/5 here in my du, and I don't have 1 over 5 here. So I cannot replace by du. So what do? You can create 1/5 in there. How? Well, multiply this expression by 1. Remember, c times the integral of f of x dx, as far as this c is constant, it is equal to c times the f of x dx. You can pull it out, that means you can pull it in. I'm gonna multiply this integral by 1, which doesn't change anything, and that 1 is 5 times 1 over 5. Guys, I multiply by 5 and divide by 5, that's 1, right? And then this 1 over 5 in the front, I'm gonna put it inside using this rule right here. And this 5, I'm just gonna leave it outside. So now I have 5 times the integral secant x over 5, secant x over 5, tangent x over 5 times 1/5 dx. So I did a little bit of algebraic manipulation to get what I needed to integrate. But you can only create a number to do that. You can never do that with a variable because then you are changing original function. Can't do with a variable. Our rule for integral, c has to be a real number only. No variable. Variable is not accepted to do so. Make sure that you only do this with the numbers. So now I'm ready to do the substitution. So this is 5 times. Remember, secant x over 5 was u, and then secant x over 5 tangent x over 5 1 over 5 dx was du. So this is equal to 5 times integral of u to the 4th power is u to the 2nd power divided by 2 plus c, which is equal to 5 over 2 times u square. Let's do the back substitution. What was my u? Yes, my u was secant x over 5, but it is u square, so it will be secant square x over 5 plus c is my final answer. Let's do another one that requires the algebraic manipulation. Example, find the integral of square root of 4 minus 3x dx. And clearly, this is a composite function. Outer function is square root function. Inner function is 4 minus 3x. So we are going to have to let u be 4 minus 3x. When you take the derivative of each side, I get du equal derivative of 4 minus 3x is negative 3 dx. And this integral can be rewritten as integral of 4 minus 3x to the 1/2 power dx. And again, you can switch 4 minus 3x to u to the 1/2 power, but now problem is I need negative 3 dx to replace by du, but I'm missing negative 3 here. So you're gonna need to multiply by quantity 1 without changing original problem. But you're going to write the quantity 1 in such a way that it would satisfy what you need. So I need negative 3, but I need to make that quantity 1. So you're gonna multiply that again by negative 1/3. So that negative 1/3 times negative 3 is quantity 1. And now you can rewrite this integral as negative 1/3 times, and then this negative 3, you're gonna put it inside of integral. So you're gonna have now 4 minus 3x to the 1/2 power times negative 3 dx. Then I have negative 1/3 times, I'm gonna do the substitution now. 4 minus 3x is your u. So I have now u to the 1/2 power, and negative 3 dx is my du. So I successfully changed this to u substitution. And now let's take the integral of that, negative 1/3 times integral of u to the 1/2 power. When you use a power rule for integral, I'm gonna gain 1 power, and 1/2 power plus 1 is 3/2. So I'm gonna multiply by reciprocal and u to the 3/2 power plus c, which is negative 2/9 u to the 3/2 power plus c. And now I need my answer to be in x. So we're gonna do the back substitution. And finally, my answer is negative 2/9. My u was 4 minus 3x to the 3/2 power plus c. And that is my final answer. Now, let's do a couple problems that involving a double substitution. I would say these two are probably hardest one in this section, but you definitely want to know how to do that. Integral of x radical quantity 2x minus 1 dx. And we can clearly see that composite function is square root of 2x minus 1, and inner function is 2x minus 1. So naturally, we would all call u equal 2x minus 1. So then du is going to be equal to 2 dx. No problem, I don't have a 2, but I know now how to create 2. So we're gonna do that. And this will be then equal to integral of x. I'm gonna change radical to power. So I have a 2x minus 1 to the 1/2 power. And I only have a dx, but I do need a 2 dx. So I'm gonna go ahead and multiply by 2 and then divide by 2 in the front. So when I substitute, I'm going to get 1/2 times x. 2x minus 1 was my u to the 1/2 power, and 2 dx was my du. Wait a minute, what is wrong with this integral? I still have an x there, and I wanted this to be all in u. so that I can integrate this with respect to u. But I have an x there, and what do? You cannot pull out that x, remember? Because this is a variable. Then what you do is you go back to your u, and then you want to solve that for x. That's easy, right? U equal to x minus 1. Can you solve that equation in terms of x? No problem. Add 1 both sides, so I have u plus 1 equal to x. I'm solving for x, so you need to divide by both sides by 2, so that your x then is equal to u plus 1 over 2, and now you are going to substitute this for your x, so this integral only consists of u expression. Make sense? Alright, so let's do that. Then I have 1/2 integral x will be replaced by u plus 1 over 2 times u to the half power du. And you can even pull out this 1/2 under the u plus 1 to the front. Since the constant multiple, we can always pull it out. So now it becomes 1/4. And you have u plus 1 times u to the 1/2 power du. And now you can distribute this u to the 1/2 power to both of u plus 1. Then you have 1/4 times u to the 1/2 power is u to the, we add exponent, so you get 3 over second power plus u to the 1/2 times 1 is u to the 1/2 power du. And now you can integrate one by one. So I have 1/4 times integral of u to the 3 over second power is, I need to add 1 power, and 3 over 2 plus 1 is 5 over 2. So reciprocal is 2/5 u to the 5 over second power plus, when I integrate u to the 1/2 power, I need to add 1 power, which makes the power now 3 over 2. Reciprocal is 2/3 u to the 3 over second power plus c. So then you can go ahead and distribute the 1/4. So 2 and 4 cancel. So you're gonna get 1 over 10 u to the 5 over second power plus 2 and 4 cancel. You get 1 over 6 u to the 3 over second power plus c. So now you can do back substitution of u, and our u was 2x minus 1. So final answer would be 1/10. U is 2x minus 1 to the 5 over second power plus 1 over 6, 2x minus 1 to the 3 over second power plus c, and we are done. Let's do one more. I have integral of x cubed times cube root of x squared plus 2 dx. So you can see that which one is a composite function, right? Cube root of x squared plus 2. And inner function is x squared plus 2. So you are going to let u be equal to x squared plus 2. Then my du is equal to 2x dx. All right. Well, I need 2x dx, but I have x cubed dx. So what you could do is rewrite this as, have an x squared there, and instead of x cubed, and cube root of x, let's change it to a power. So I have x squared plus 2 to the 1/3 power, since it's a cube root. And remember, I originally had an x cubed, so I'm gonna make that as a x squared times x dx. Because my du is 2x dx. I can create 2, but I cannot create x. And good thing is, I do have a factor of x from x cubed. So then now, you can of course clearly create 2 that you need by multiplying by 2 and divide by 2. And we're going to substitute, of course. And now, you already know that when you substitute, this will be substitute, this will be substitute, and your problem's gonna be x squared. That x squared needs to be rewritten in terms of u. So what do you do again? You go back to where your u is, and good. This u is x squared plus 2. So can you solve for x squared that you want to replace it by? No problem. So all you have to do is subtract 2 both sides. When you subtract 2 both sides, you get u subtract 2 equal x squared. So you can replace even x squared by u minus 2. So now I'm ready to substitute everything. That's a 1/2 times. My x squared is u minus 2 times x squared plus 2 is u to the 1/3 power times 2x dx is my du, which is equal to 1/2 times. Now go ahead and distribute. I get u to the u times u to the 1/3 power is 1 plus 1/3 power is 3 over 3 plus 1/3, so you get 4/3 power minus 2 times u to the 1/3 power du. So then, from here, it's easy integration. I do have a 1/2 times. 1/2 is multiplied to this whole integral. That's why I'm putting bracket even earlier too. And then constant of integration, I just need to add at the end. And then when I integrate u to the 4/3 power, I need to add 1 power, and 4/3 plus 3/3 is 7/3. So you get 3 over 7 u to the 7/3 power minus 2 times u to the 1/3 power. When you integrate that, I gain 1 power, and 1/3 power plus 1 is 4/3. So reciprocal is 3/4 u to the 4/3 power. So now, when you distribute, I get 3 over 14 u to the 7/3 power. This cancel, so it's a 3 over 2 u to the 4/3 power, but it's going to be multiplied by 1/2 as well. So now you get negative 3/4 u to the 4/3 plus c. So all I have to do is now back substitution and write my answer in terms of x. And my u was x squared plus 2. So therefore, my final answer will be 3 over 14. U is x squared plus 2 to the 7/3 power minus 3/4. My u is x squared plus 2 to the 4/3 power plus c. And that is my final answer. All right, this is perfect place to split this section in half. So have a break and see you again in 4.5, part 2.